Hello everyone, this is Dr. N.G. Praveena working as Associate Professor in the Department of ECE at R.M.K. College of Engineering and Technology. In this video lecture, I am going to discuss about the small signal analysis of common drain MOSFET amplifier. The highlights of this video is we are going to analyze the input resistance, output resistance and voltage gain for a common drain amplifier. You must remember common drain amplifier is otherwise called as a source follower circuit. So, in this slide I have shown the circuit diagram of a common drain amplifier followed by its small signal equivalent circuit. Now look at the circuit diagram. When we observe the circuit diagram, you can see here the gate is going to act as the input terminal and the drain is going to act as a common terminal and the source is going to act as an output terminal. When we look at the circuit, the resistance R1 and R2 is going to act as a potential divider circuit. The coupling capacitor CC allows only the AC signal and it blocks the DC component. Now from using the circuit diagram, we are going to draw the small signal equivalent circuit. How to draw it? We are going to apply 3 steps to find out the small signal equivalent circuit. First one is we are going to replace the DC voltage by a short circuit. When we look at the circuit, the DC voltage is nothing but VDD. So, we are going to replace VDD by a short circuit. And the second one is we are going to replace the coupling capacitor by a short circuit. So, this has been replaced by a short circuit and VDD has been replaced by a short circuit. And the third one is we are going to replace the MOSFET by its small signal model. So, I am drawing a generic model here. We have gate, drain, source. Between gate to source, since it is open circuited, we have a voltage said to be VGS. Between drain and the source, we have a current source. The current source is nothing but GMVGS. The current, since it is an N-channel MOSFET, the current flows towards the source. So, I have drawn like this. Then across this, you connect an output admittance R0. Okay. Now, apply all these 3 things in the circuit diagram and redraw the small signal model. So, Vi followed by RSI. Now, capacitance shorted. See, look at this R1 and R2, how they are connected. R1 and R2 are connected in parallel. Now, since it is a common drain amplifier, gate is going to act as an input terminal, source is going to act as an output terminal and drain is going to act as a common terminal. So, between gate and source, we have a voltage said to be VGS. Between drain to source, we have a current source GMVGS. The current flows towards the source. So, here the current direction is flowing towards the source. Across this, you connect resistance R0. Then look at the output circuit. You have a source resistance which is connected across the source. So, you connect Rs. Okay. Now, for this circuit diagram, you find out the input resistance. How to find out the input resistance? Here, it is nothing but the resistance what we observe across the input circuit. It is nothing but between gate and drain. Now, look at the circuit carefully. When you observe it, it is nothing but R1 and R2 in parallel. So, I can write Ri is equal to R1 parallel with R2. Now, we are going to find out the output resistance. So, how to find out output resistance? So, here 2 things has to be done to determine the output resistance. Number 1 is you have to remove the input source. If it is a current source, open circuited. If it is a voltage source, short circuited. Here I have a voltage source, Vi has been replaced by a short circuit. Okay. And the second one, this is the first thing I have to do. The second thing is we connect a voltage source across the output and known voltage source has to be connected across the output. Say it is Vx. Due to this known voltage source, I have a current that is said to be Ix. So, for this circuit, we are going to determine the value of the output resistance. So, R0 is equal to Vx by Ix. Now, we are going to find out the expressions for this and substitute here in order to get R0. Now, for that what we are going to do is, we are going to assume this A point. This is my A. Okay, I am assuming node A. So, apply KCL at node A. Hope everybody knows KCL. Entering current is equal to leaving current. So, when you look at the node A, entering current is GMVGS and the other entering current is Ix. What are the leaving currents supposed to be? One across RS and one across R0. One flowing through RS and one flowing through R0. So how can I write? It is nothing but Ix plus Gm Vgs is equal to Vx by R0 plus Vx by Rs. Now try to understand, since Vi is short circuited, the entire branch will be shorted. Now this voltage, okay, Vgs will lie between this point and this point. The upper terminal will be negative and the lower terminal will be positive. Now relate Vgs with Vx. Now Vgs minus plus, Vx plus minus. So how to relate that? So simple. Substitute Vgs is equal to minus Vx. So replace Vgs by minus Vx. That is the thing I have done here. Now rearrange the terms in such a way that put Ix terms on one side and take the Vx terms on the other side. So I have done the same thing here. Now when you look at your LHS of the expression, take Vx common. So I have taken Vx common. So from this you find out what is the expression for Ix by Vx. Now try to understand, this is the admittance I am finding. See, 1 by R0, I am finding the admittance. I am finding the value of what? Admittance. So in admittance, when the resistance are in series, when we put this thing, okay, to in terms of impedance, then this resistances will be in parallel. So I am finding directly the impedance. So R0 is equal to, reciprocal of this value will give you the impedance. So R0 is equal to Gm has been written as 1 by Gm, 1 by R0 has been written as 1 by R0 and 1 by Rs is written as what? Rs. So output resistance of the common drain MOSFET amplifier is R0 is equal to 1 by Gm parallel with R0 parallel with Rs. And the next thing is, we are going to find out the voltage gain. How to find out voltage gain? Voltage gain is nothing but AV is equal to V0 by Vi, V0 by Vi. So find out what is V0. So from the output circuit, find out what is V0. So simple. Here you can see a current source entering. This is your positive terminal and this is your negative terminal. So the current enters positive terminal, and what about these two resistance? They are in parallel. So I can write V0 is equal to Gm Vgs into R0 parallel with Rs. So we have determined the value of V0. Now how to find out Vi? So you are going to apply KVL at the outermost loop. So here I am going to sum up the voltages at the outermost loop. One is Vn, the other one is Vgs, the third one is V0. So Vn equal to Vgs plus V0. You replace V0, okay, V0 by your second expression. Right, from this expression take Vgs common, so I got Vn. But our intention is to determine Vi, not Vn. So apply voltage division rule at the input circuit. So Vn is equal to, I can write down Vn is equal to total voltage is Vi, same branch resistance is R1 parallel with R2 and the opposite branch is RSI. Apply this and write down. So what I get? Vn is equal to Ri divided by Ri plus Rs into Vi. Now rearrange the terms and find out what is 1 by Vi. So I have obtained 1 by Vi. At the same time, I have replaced the Vn expression, okay, by this one. So replace the thing, both the thing I have done in the same step. So replace it. Now you have obtained the value of V0 in the second expression and you have obtained the value of Vi in the third expression. Now substitute 2 and 3 in 1. I have substituted 2 and 3 in 1. After substituting, when we observe, you can see here some terms are common. So Vgs is common, you can cancel it out Vgs in both the numerator as well as the denominator. The remaining terms will give you the voltage gain. So this is the voltage gain of a common drain amplifier. AV is equal to V0 by Vi is equal to minus Gm into R0 parallel with Rs into Ri divided by Ri plus Rs into 1 by 1 plus Gm into R0 parallel with Rs. Hope you understood how to do the small signal analysis of a common drain amplifier. We discussed in this video how to derive the expressions for the input resistance, output resistance and voltage gain. Thank you all.